Good day, everyone. Welcome to Google Cloud Next 2020 On Air Extended. I know it's a really long title. Just bear with us. That's all the way things goes. So this is our GDG POS second or third event for the year, and it's just basically about Google Cloud. Okay. So we have a simple agenda today. We're just gonna give a brief intro about cloud, and then I have some videos from the actual online event, Cloud Next on Air. Then we'll have our keynote discussion, Cloud for Devs, sorry, with our Googlers, Trini Googlers, and then I'll wrap up and talk about how you can access cloud training. So without further ado, let's start the presentation. Okay, I'm seeing that there's an echo. Okay, so just getting a little feedback here. Okay. I'm just gonna check in chat. Can you hear me? All right, so let's talk about cloud computing. Well, cloud computing is basically offsourcing your computing resources to that of the cloud. So as opposed to the traditional on-premises approach, the resources that you access are really managed and provided by somebody else. Cloud services are usually segregated or categorized around these three pillars, although there are more categories that we would see, but these are the more go-to terminology that we typically encounter. Software as a service, platform as a service, and infrastructure as a service. So software as a service is when you outsource applications, right? So there are software applications that G Suite, for example, G Suite provides, and you run these applications totally on the cloud with no installations required. Then going along at the bottom, there's infrastructure as a service, whereby most of the actual hardware is provided to users via the internet. So you have control over things like network configurations, the operating systems, as much as possible, access to they call it the bare metal. And then in between is the hosting logic. So there may be already some control that you give up that you would typically have in infrastructure that is then available in platforms. So some decisions are made for you, and we'll talk a bit about the difference in the upcoming session. Right? But examples of those are like Heroku, Cloud Foundry, AWS Lambda. It's like some software is installed but you still have flexibility on what you could run on top of that. And then there are some gray areas because in between these other levels, there are other kind of services that you can't get from the cloud, and it's really hard to fit them in, one bucket over the other. So they kind of sometimes they call database as a service or the software, platform software as a service, things like AWS Kinesis, RDS, Windows Azure SQL, because it's more like the database. But then again, you don't get full access to the machine. So it's a middleware layer. And then there are other gray areas between PaaS and SaaS, right? So like example, Google App Script and App Maker. these different levels basically comes down to what level of control is available to the user, right? Um, for example, IaaS, you have access to the applications, data, runtime, and OS. All of that is managed for you. Managed by you. Whereas in software as a service, you just really running application services or just really running software. Okay, so that's the thing about the cloud, that we will see the different services. It's according to how much control you want that will guide your decision into whatever particular service you're interested in. So Google Cloud, it can be further broken up into two things. They have the Google Cloud Platform and then G Suite. So we should be familiar with G Suite, all the different apps that are available like Docs, Sheets, Forms, Gmail, Hangouts, Meet, Drive. And then there's the Google Cloud Platform, which will be putting some more emphasis on during this event. So as you can see, there are many offerings and it can be very overwhelming. However, compute options, from a perspective, the compute option seems to be more the kind of services that we're more interested in. How can we have our apps and deploy our apps and maintain our apps in the cloud? So in G Suite, you can programmatically access these software packages. So yeah, and that they allow you to extend the functionality. So for example, in Google Docs, there are extensions you can install, which are third-party software that's actually built on top of the G Suite platform products. So for example, I used the Mail Merge plugin the other day and allowed you to link up Gmail with Google Sheets and basically set up automated emails. And those would use the G Suite APIs, right? So they allow you to programmatically tap in to those resources. And then there are the GCP APIs, which let you to programmatically tap into the resources of the Google Cloud Platform, right? Things like talking to the cloud data store, things like cloud functions, automatically deploying things on the compute engine. Those what you would use GCP APIs for, including maps and YouTube. So Compute Engine is the first service we look at today. It delivers configurable virtual machines from all sizes with many different configurations. There's high compute, there's high memory, there's there's things that allow that are better suited for VM workloads, and we have a video a bit on that in a moment. Then there's App Engine, right? Um, with Google App Engine, you don't really have to. Then again, here it is again where we're shifting focus on what we want control on. So with Google App Engine, you don't think about the hardware. You just deploy your code, right? So it's a platform as a service where certain decisions are made for you, and you can just get your code up and running once it's on a platform that's supported by Google App Engine. And then even getting more granular, we have cloud functions. Maybe um, you don't have the entire app or you don't want to deploy the entire app. You just want certain functions to be called on certain triggers. You would use the Google Cloud Functions offering to do just that, right? And they're really great. They really work well with Firebase in terms of triggering things that happen according to changes in your database or certain events. So even HTTP hooks. Then we have Cloud Run, which really works great with apps that you are containerized, right? So if you want to just if you have an applications, and we'll talk about containerization in our keynote event, our keynote presentation. If you have your app and you have it containerized using Docker, for instance, you can push that onto the Docker registry and get that deployed and auto scaled and entirely managed for you on Google Cloud Run. Next, we're talking about storage. Right, so these are these services that allow you to store data, whether it's media or actual user data from users using your application. So Cloud SQL is a high-performance, fully managed SQL hosting service or SQL database hosting service from Google Cloud. Supports MySQL, Postgres, and SQL Server. And we have Cloud Data Store for those who may be interested in storing data that's not in the SQL function. So it's the document-based data storage. And then, of course, we have Firebase, which is the real-time database, which also takes a document JSON-like structure. But where the main selling point is that fast, consistent, real-time updates that you can get from the service. So since the Firebase real-time database has been around for a little while, they introduced a secondary data store called the Cloud Firestore. So it's another NoSQL database, but what it does support is collections and different querying options. So it's really the best of both worlds, the next generation of the data store. Plus, it integrates the real-time features from Firebase. Then we have the machine learning, right? So Google Cloud provides a set of machine learning tools to get you started with running ML in the cloud for varying levels of proficiency in ML, right? Whether you're running pre-trained models already there or you're uploading your own model, there's a service for your use case. So now sit here, you can use pre-built models, you can build custom models, and you can extend models that are already available. Then we have BigQuery. So when we're talking about big data, we need technologies and tooling so we can make analysis cost effective. So let me just start. Google BigQuery is a fast, highly scalable, and cost effective and fully managed data warehouse in the cloud for analytics built with built-in machine learning, and you can issue SQL queries across multiple terabytes in data. So this is when you have really large data sets, so you need to find a way to wrangle them and answer certain questions about your organization. This is what BigQuery is for. Another part of the machine learning offering is the Cloud Natural Language. So the Google Cloud Natural Language API reveals the structure and meaning of text, also provides context classification, sentiment analysis, and allows for multilingual transcription and translation. So these are just a couple of the services that are available from Google Cloud. I'm not going to go through all of them, but I'll end this presentation here to now switch to a pre-recorded presentation from Google Cloud onAir about selecting the right compute option. Just give me a minute. I'm going to share back my screen. Okay.
Hello, everyone. My name is Hanan Youssef, and I'm a product manager on Google Compute Engine. Today, I will be sharing with you an overview of our virtual machine offerings and how they can help you run your applications effectively, efficiently, and seamlessly on Google Cloud. I hope that after this session, you'll be able to identify the different options that are available to you on Google Cloud, and that you'll be able to leverage them to run all your workloads on GCP. Let's get started. I wanted to start with a quick statement from Robert Insland, our head of sales. This statement really summarizes one of our main goals for Google Cloud. We believe that your cloud experience should be easy, simple, and pleasant. The best infrastructure experience is the one that shouldn't require extensive research and analysis before each step. Thus, we aim to be the easiest cloud for the enterprise. And Google Compute Engine is no exception. With that in mind, we'll be taking you through the different ways that we're making our VM offerings simple and seamless for you. At its core, Compute Engine lets you easily create, provision, and run virtual machines on Google's infrastructure. You can create a VM, choose between predefined or pre-configured machine types, or create your own custom machine shapes. You can also leverage our recommendations platform, and you can leave a lot of the operational overhead to us with capabilities such as live migration. You can also automatically save money with sustained use discounts and even enjoy deeper savings when you sign up for committed use discounts. Our focus today will be on the first two pillars of this experience, the ones that are under VM types on this chart. So why is this important? It's important simply because you will see that Compute Engine is foundational to almost everything you do in the cloud. It's foundational to the applications you want to run, to the success of your digital transformation, as well as the modernization of your data center and your cloud operations. And because of that, we believe that your infrastructure matters. This makes it important for us to make sure that Compute Engine is the right decision for your business when it comes to providing the right resources in a comprehensive and flexible way that accelerates your innovation. Compute Engine provides you with the right business decisions to deliver the right resources to your teams with simple, transparent, and fair pricing. The tools to optimize cloud spend and pay for what you use, and nothing more. Also, the reliability and security you need to run your mission-critical applications. Compute Engine also tries to offer you everything that you need. Everything that you need to digitize your business so that you can choose your resources based on the business requirements with the flexibility to adapt as your workload changes. You can get access to a variety of predefined and customizable VM families, coupled with flexible consumption models. You can configure your machine types for best fit and optimal performance. Right sizing helps you get the best balance for performance and pricing. And the wide variety of VM families help you get the tailored support for your diverse computing needs. Our VMs are designed with all that in mind. They are designed for real-world scenarios so that you can run the workloads you want in Google Cloud and take advantage of an optimized computing infrastructure that provides you with the right capabilities for all your application needs and helps you accelerate your cloud transformation. This can help you get your scientists in front of innovation and your data analysts in front of insights and your mission-critical applications in front of your workforce. We do that by offering virtual machine types that fit the different types of workloads you might be running. Across our offering, we focus on three key pillars that you will see me covering today. The first one is that our virtual machines will always offer you leading price performance to ensure that you are running your applications effectively and efficiently, and that you are seeing improvements year over year. We do that by leveraging innovations across CPU vendors, and also by leveraging unique Google technologies that we've used internally for years to run our own infrastructure. We also realize that your workloads are not equal. Some of them optimize for high CPU performance, while others focus on high-end memory configurations for business-critical databases. You will see that our offerings are optimized for these different requirements, and they prioritize the needs of the different applications. The third pillar is that we know that you don't run on just a virtual machine. It's all about the end-to-end experience and the end-to-end capabilities across networking, storage, and compute, and other capabilities that make up your infrastructure experience. And because of that, the offerings we'll be discussing today really cover the spectrum and make sure that you can get all the capabilities that you need. Our VM families, our virtual machine types, come in several shapes, from general purpose to workload optimized. Starting on this chart from the left, you'll see that our general purpose VMs are simple, flexible, and the best fit for the majority of your workloads. E2 are our general purpose VMs that allow you to benefit from deep savings, up to 30% of our general purpose pricing. This family of VMs is great for customers who do not have application dependencies on a specific CPU architecture. You simply pick the amount of vCPU and memory that you want and we'll provision it for you. We proactively adjust the capacity for the entire fleet to optimize utilization, and that means that we give you whichever processor family is available. Based on that, we enable you to save a lot by leveraging E2 VMs. The second VM type that we will talk about today is the family of general purpose VMs N2 and N2Z. These are our most flexible VM types. They offer leading performance per dollar, the latest CPU architectures from both Intel and AMD, and a wide range of shapes and capabilities. You can simply attach a lot of other preferences to these VMs. N2 and N2Z are the next generation following N1 VMs, offering a significant performance jump. Now let's move to the workload optimized VMs. Compute optimized VMs are the best fit VM type for compute intensive workloads, including AAA gaming, electronic design automation, and high performance computing. They are powered by high frequency Intel scalable CPUs and offer approximately 40% higher performance compared to other GCE VMs. Next on this list are our memory optimized VMs. They are the best fit for memory-intensive workloads, including in-memory databases like SAP HANA, in-memory analytics, and in-memory cache. Memory-optimized VMs offer the highest memory configuration available on GCP, and they can be configured with up to 12 terabytes of memory today. Finally, we're working on a new GPU-optimized VM type, A2, that will offer the latest GPUs available and will be available later this year. Now let's start going into these different VM families and let's understand how they fit your different application requirements. We'll start with general purpose VMs, and we'll start with E2. For general purpose workloads that prioritize cost savings, E2 VMs offer up to 31% savings compared to N1 VMs on both list and commitments pricing. This makes them the lowest total cost of ownership, or TCO, offering available in Google Cloud. They are a great choice for web servers, small to medium databases, dev and test environments, and many applications that don't have strict performance requirements. They offer a comparable performance baseline to the current N1 VMs for those of you who have been using them. E2 VMs are available with up to 16 vCPUs and 128 gigabytes of memory. And they also support flexible configurations through custom machine types that enable you to right-size your resources. Some constraints you should be aware of is that E2 VMs run on any available CPU in our infrastructure across Intel and AMD. They also run across older and more recent CPU generations. You cannot select your CPU. These VMs do not offer you the ability to attach local storage or GPUs. However, they benefit from dynamic resource management, which is an efficient scheduling mechanism that enables us to give you only the resources you need and leverage live migration to move you to a server host with more resources as your application asks for more. This Google technology brings you a lot of benefits as long as you have a flexible workload that can benefit from these resource constraints. To assess the benefits to your workload, you can look at the potential performance per dollar improvements shown on this slide. We're showing here examples of some benchmarks and how they leverage the E2 cost savings. For example, you can see approximately 30% higher throughput per dollar for web serving workloads. The same benefits are also available when looking at benchmarks that represent app and dev testing. For workloads that could benefit from these improvements, E2 also offers a large list of upcoming features that you can look forward to. We are continuing to expand the capabilities of E2 VMs with new features that include making them generally available in more GCP regions, making them leverage AMD CPUs as well as Intel CPUs in more locations, and also for the first time offering committed use discounts for shared core smaller VMs so that you can even get more economic benefits. And finally, we're continuing to look at new machine types that would expand the available configurations too. Now let's move to N2 and N2D VMs. These VMs are the best fit for a majority of your general purpose workloads, as they prioritize flexibility and offer leading price performance. N2 and N2D VMs are a great fit for your enterprise applications, databases, and many of your web and app serving workloads. They are also our most flexible VM offering. They give you a wide feature set, enabling granular control of your resources and coverage across capabilities that range from sole tenancy to the flexibility to add and remove storage at any point, for example. General purpose N2 and N2D VMs are designed to support a variety of workloads. By offering a perfect balance of compute and memory resources with up to 200 vCPUs and 800 gigabytes of memory. Flexibility is really a core priority and differentiator for this VM family. Our VMs, our virtual machines under N2 and N2D, enable you to right-size your resources, which is a great cost-saving feature. They also enable you to auto-upgrade to new CPU generations as we launch the latest architectures in the market. This means that you can simply choose a minimum CPU platform, and Google will automatically run your VM on the latest CPU generations. You can attach up to 9 terabytes of local storage per node, and you can get the highest networking performance with 32 gigabits per second. These VMs are also being rolled out globally across all of our Google Compute Engine regions. Thinking about the key differences between N2 and N2D VMs, you can see an overview summarized over here. N2 VMs are our general purpose Intel VMs, supporting the latest second-generation scalable processor from Intel with up to 80 vCPUs. They come with approximately 20 to 30 performance improvement, giving you a great price performance benefit over the older generations. N2D are our AMD-based general purpose VMs. They leverage the latest EPYC Rome CPUs, and they come with up to 224 vCPUs per node. They even offer you a lower price point with approximately 13% lower pricing versus comparable VMs. Now let's move to some benchmarks and show you how you can benefit from our latest general purpose VMs. Over here, you can see a wide range of benchmarks showing improvements that range from 25 to 30% for most workload types. You can see that N2 VMs show great improvements when looking at benchmarks like SAP Benchmark DB, for example, which represents high-end databases. And over there, we can see 30% higher SAPs compared to comparable VM types. When we look at benchmarks like Chromium Compile, you can see that you're achieving approximately 25% improvement in build time, a great example of the benefits that you can see with N2 VMs for many of your applications. Now let's look at some benchmarks for N2D. As you can see, there are many benefits that we can see when looking at data management workloads, given that these leverage AMD's higher memory bandwidth and higher persistent throughput, which is available with the larger VM shapes. We've actually seen up to 2x performance improvements for some workloads like video streaming, which are represented here through the stream benchmark. And they show how this higher memory bandwidth can be of great benefit to many of your workloads. So in summary, N2 and N2D VMs offer a wide range of capabilities and also have a rich roadmap as we think about the capabilities that we're bringing soon to these VM types. Features that we're working on range from bare metal instances to higher networking performance with up to 100 gigabits per second. We're also working on bringing you the latest CPU platforms across both Intel and AMD, and you will see those continuing to come very quickly to these instance types. Now that we've covered the general purpose VMs, let's move to some of our workload optimized VM families. We'll start with compute optimized VMs. Performance-sensitive and compute-bound workloads come in many shapes and forms. They might be high-performance interactive web servers, AAA games, high-performance computing across simulations, genomic analysis, or media transcoding. They might also be applications that have very expensive per-core licensing and thus would benefit from higher per-core performance. All of these applications have one thing in common. They would see great advantages from leveraging the higher per-core performance and the fastest CPUs you can give them. And this is where compute-optimized VMs can really supercharge your applications. The compute-optimized VMs are one of our latest additions to the Google Compute Engine virtual machine portfolio. They offer the latest CPUs, Intel scalable processors, Cascade Lake. They offer the highest frequency per core available on Google Compute Engine with up to 3.8 gigahertz. And they offer multiple shapes that go from 4 vCPUs to 60 vCPUs. They also enable you to attach local storage if that's needed by your application and offer you up to 32 gigabits per second networking bandwidth. With capabilities such as NUMA-aware performance and higher performance per thread, as well as higher isolation for latency-sensitive workloads, these VMs can offer you a great boost for many applications. Looking at how this can benefit you, let's look at some of the benchmarks over here. These benchmarks represent both highly interactive applications and higher performance computing workloads. The results are evident. All of them see approximately 40 to 41% performance improvements. This can see over here in the increase in the average queries per second, and also the decrease in the average runtime seen under OpenFOAM. With these benefits in mind, we also wanted to share with you some of the capabilities we're adding to the compute-optimized VMs over the next few months. These include bare metal instances support, as well as an increase in networking performance with 100 gigabits per second coming soon. As we've mentioned for the general purpose VMs, we're also always looking at the latest CPU innovations so that we can always offer you improving price performance as you utilize some of these VM capabilities. The second family under our optimized VM types is memory optimized VMs. Memory optimized VMs are designed for high-end business critical applications and specifically SAP. They are a great fit for in-memory databases like SAP HANA, in-memory analytics, and in-memory persistent cache. They offer you the highest memory per core available on Google Compute Engine and the lowest price per gig of memory as well. They feature the latest and fastest memory technologies and come in different shapes that range from 1 terabyte of memory per node per VM up to 12 terabytes per node, which is really enough memory to run your most memory-intensive applications. In addition to the shapes and capabilities of these VMs, they are also optimized for flexibility and simplicity. For example, capabilities like live migration helps you minimize downtime, even as you run workloads that require 12 terabytes of data in memory. We can take away a lot of the overhead for operating those VMs. They also come with flexible commitments across all the memory optimized shapes so that they can continue to grow with you as your data size grows. A great example of that is illustrated over here when we look at some of the customer case studies for our customers who've been using those VMs. And referencing one of the testimonials we've seen customers with 9 terabytes of SAP data that is growing approximately at 1 terabyte per year. So for them to be able to leverage our flexible commitments and the many sizes we offer simply means that they can maintain support for their data size as it grows on our platform. If you have workloads that would benefit from these memory configurations and would benefit from the memory optimized VMs, you also have a lot of capabilities to look forward to. Some of the capabilities that are coming soon to our memory optimized VMs include higher networking and storage performance, as well as additional SAP certifications, and of course, newer CPU platforms and additional chips so that you can always right size your VM to the requirements of your applications and your databases. Now that we've given you a quick overview of all of the VM families and virtual machine capabilities available on GCP, we wanted to leave you with a few statements on how to best get started with these virtual machine types. So for your workloads that would benefit from the memory optimized VMs, we also have a very rich roadmap that you can look forward to. This includes networking and storage performance improvements. We're looking at 100 gig enhanced networking capabilities, as well as new capabilities under extreme storage, extreme persistent disk that would bring you the highest storage performance for these large VMs. We're also looking at more SAP certifications so that you can run more workloads on these virtual machines. And as always, we're looking at newer CPU platforms, as well as additional shapes so that you can always right size your VM and leverage only the resources that you truly need, minimizing waste. Now that we've taken you through all of our VM types and families, we wanted to leave you with a quick guide for how to get started with these different VM types and these different VM families. We look at this as a simple 3-step process. For the first step, consider your resource specs. What are the shapes and resources needed by your applications? How sensitive are you to specific CPU architectures? Do you, for example, need to use something like Intel AVX 512 and need to make sure that you're running on CPUs that have this capability? Do you need to qualify every new CPU architecture, or are you more flexible in terms of the underlying hardware? After you've thought about that, we would recommend that you start thinking about price performance. Which of your applications would benefit from higher performance? Which of your applications are highly interactive, where you need the shortest runtime and the best latency, for example? That would be one category of applications that would benefit from our highest performant compute instances, like compute optimized VMs. On the other side, what are the applications that would be a great fit for additional cost savings? Over there, we would recommend that you look at VM types like E2 VMs, for example, that can give you a lot of cost savings. So once you've had a chance to look at your resource specs and look at your pricing and performance priorities, now it's time to think about deployment planning. As you think about your deployment plan, we would recommend you start looking at your capacity requirements and looking at the regions where you want to be running your VMs. You can also find a lot of resources on our Google Compute Engine documentation pages that can guide you through the migration process. This concludes our overview of the Google Compute Engine virtual machine types introduction today. We hope that it was useful and that you have a lot of information to get started with. Thank you so much for being with us today. That's all for today.
Okay, so that was just one of the presentations from Google Cloud Next on Air. And as you can see, it's very technical and it's guided towards a very professional IT managerial kind of audience because those are the people who will be making, the decisions for enterprise companies. So that is why they give so much detail. And that's just to give you an overview. Now, for the dev side of things, what we would typically use in Compute Engine, at least I would imagine, are the simpler VMs for our little startup apps. And one thing I noticed that this video didn't really address is the free tier. So I'm going to show you how you can get information about the free tier here. That's a long link. Just have to go cloud.google.com slash free, right? And well, the free tier is just basically a set of Google Cloud products that are available without any cost. Now, now, Google Cloud, as most cloud providers, the big thing is the little hiccup about it is, even though it is free, you still need to provide a credit card, but and information just in case you may upgrade one of these services or your usage just crosses the what is allowed from the free limits, right? But I can tell you that I've been using free tier for months now. Right, I'm using many different APIs. I'm using Firestore, and my bill has been $0. So, for example, I've been using it was storage. I've been using storage, and I have a couple of gigabytes of video recordings and what's up in storage. I've been using Firestore and Cloud Functions, but the in compute engine there is a free tier for that as well, and those are the F1 instances. So they didn't cover F1, they did E and N, but the F1 instances are very small instances. I can't really tell you off the top of my head of how powerful they are, but they've been for my use building simple apps, simple, blogging sites. I've even seen tutorials that allow you to deploy a WordPress setup on an F1 instance as well. So there are very generous limits. At least I think I'd imagine if you need to cross more than these limits, your application probably should be making some money to actually afford the paid version of these offerings. Okay. So how does the Google Cloud Console experience look like? How does it look like to set up a VM or an instance? Well, to answer that question, I have another presentation for you here. Is how to deploy a web server on GCE. So you notice today is more of a micro event. We're just a lot of pre-recorded things that we're bringing and showing you.
Everyone. Welcome to this YouTube channel. Please like and comment if this video helps you and subscribe to this channel to get updates about the new content.
In this video, I will show how to install a Nginx web server on a Google VM instance using Google Cloud Platform UI. I'm now logged into my Google Cloud Platform console, and as we can see, I have a project called Workshop Demo, and I can see a dashboard for my project. Let's go to the Compute Engine. I can go directly from here, go to Compute Engine, or I can go to the navigation menu and inside under Compute, I can say Compute Engine VM instance. This has opened my Compute Engine VM instance dashboard. To create an instance, I simply click on Create Instance, which is going to give me a web form to fill all the values, and Google will create a VM for me. So let's begin with filling this form. This is a name of instance which is going to live for the complete life cycle of the instance. So I can simply give Nginx web server. Can provide the labels as well to identify your application. So I can put application Nginx and save. Now I can choose my region where my VM instance should live. So I will choose Europe West to London and a zone Europe West to C. The machine configuration could be a different one, a general purpose or a memory optimized if my application is memory heavy, or a compute optimized. For this demo perspective, I'm going to just use general purpose, and that too a machine type of very small machine, F1 micro, which has a 1 CPU and 614 memory. Now, Google allows to choose a different boot disk. There are some public images. If you have a custom images, you can see it from here or a snapshot or so on. I will use a public image that too for a Debian operating system. There are other options available and Debian 9. I can also increase the disk size if I need to, but I will leave it to a 10 gig, which is sufficient for this demo prospect. Now, under service account, we can choose what service account we want to attach to this VM instance. I will leave for the default at the moment, and access scope allows which APIs I can access from this VM instance. So I will leave that as a default. Then the firewall rules, what firewalls are needed to be on this web server. I will leave this as a blank and we'll see later in the video how this affects the connection to our web server. So this is a simple form which we have filled. Now, if we want to create the VM instance using a REST API in your favorite programming language, it also gives a REST equivalent which can be used, or a command line command to create the similar VM using the G Cloud. But for now, I'm going to hit on create to create the VM instance using the UI. So as we see now, the Nginx web server is coming up. It might take a few seconds to come up. So it has now come up. So it's a plain VM instance which has a Debian 9 operating system. I'm going to SSH into it and install software packages. Now I'm logged into the VM instance. First, I will update the apt and then install Nginx software package. I will restart the Nginx server. So Nginx should be running. Now let's run ps command to check the Nginx process. So we see the process is running, and we can quickly check if it's listening on port 80 for this process. So yeah, it's listening, and we can do quickly a curl command to verify we are getting the Nginx web server. So yeah, so the Nginx web server is running. We are able to connect to it internally. Now let's go to the web UI and see if you're able to browse the UI from here. Now we are trying to open the port 80 web page, but it's not coming. The reason being, we have not allowed any traffic on port 80 from the workstation to this web server, which lives within the Google. Remember, we unticked the allow HTTP traffic under the firewall. That's the reason we haven't set any firewall rules. So let's go edit this VM and set the firewall rules. So click on edit and we can say allow HTTP traffic. If the application has traffic on port 443, we can say allow HTTPS. But for this demo, we just need allow HTTP traffic. And I'm going to save this thing. Now this is saved, and we can see it has allowed HTTP traffic, and we can see the Nginx web page. So this is a one way to deploy a web server on Google VM instance. In this method, we logged into the web server manually and ran all the steps manually one by one. We can also create a script which runs as and when the VM comes up and install all these things for us. So let's see the second approach of using the script. Again, I'm going to click on create instance. I will say web server 2 fill the label application as web server, click on save, again the same region, and probably choose a different zone. F1 micro, I will leave the image and everything as it is. I will click allow HTTP traffic for now. So under this section, what I can do is I can provide a startup script. So once the VM is up, it is going to run this script and do all the things which we define in the script. So I'm going to put us the same step which we did as a script here with some comments and click on create. The web server is now coming up. So web server is up. Now it will install the Nginx package. We can track that using this clicking on the serial port 1, which is going to show us the console output, what this VM is doing at this stage. And we can click on refresh to see. So we have seen it says installation complete, startup script complete, which means it has run our script successfully. Now let's get the VM's IP and see if it's showing us an Nginx page. Get a welcome to Nginx web page, which means it has installed the Nginx web server using the startup script. That's all for this video.
Thank you for watching this video. Please like and comment to provide the feedback. Finally, please subscribe to this channel to get the latest updates.
Okay, so that was a
Hi everyone,
tutorial.
and welcome to this tutorial about setting up a basic web server on the
That was a quick video of how the GCP looks. So it's a cloud platform, so it can be overwhelming with all the options and services. Now for our keynote presentation, which is Cloud for Devs. So I'm going to get right into it. And about cloud from a developer. Okay, good day everyone. Today we have a special talk as part of it's a really long name for the event, but it's Google Cloud Next onAir 2020. And this talk here we have Akash from Google Cloud, the Google Cloud team, and we have Arthur from the Firebase team. And here they're about basically to talk to us today about what we can use cloud for, talking about cloud from a developer perspective. So first and foremost, maybe Akash, you could just give us a rundown. What is Google Cloud?
Yeah, sure, man. Nice to meet everybody virtually. Google Cloud it started off as a platform for hosting code. It started off as this product called App Engine, and then that evolved into what it is today, which is a multi-product offering where you have everything covering from AI and ML all the way down to your traditional VMs and everything in between. One of Google's claim to fame is Kubernetes, which I know Nick want to talk about in a little bit. Kubernetes is basically a containerized orchestration tool that Google built and open sourced to everybody, and now all of the major clouds adopted it. And yeah, I guess we'll talk a little bit more about that as we get to that. But in general, Google is a cloud platform that encompasses everything from your traditional infrastructure as a service, which is your VMs, to everything more advanced to serverless, which are things like your big queries and your data analytics and your AI and ML, and everything in the full spectrum in between.
Okay, so that's interesting. Thanks for that. Well, I was talking with Arthur right before the stream, and one thing I was getting, well, this event is about Google Cloud Next, which is another event, and we will be showing we'll be showing the links to all of those videos to our viewers. But one thing for me, my particular experience is that some things really go over my head.
Mhm.
And I feel like maybe I'm not as IT as I think I am. I wonder if you could shed some light as to why it feels like maybe I'm not the exact target audience.
Yeah. And as to be honest, that's a common thing, right? Like the I guess the difference with Google Cloud, and even I felt this coming into Google myself. Google is an engineering company by design, right? Unlike the other clouds. So the way that our documentation was, the way that our tooling is designed, all of those things are built purposefully with the assumption that there is some level of there's some competency of the particular technology or product you want to use coming into the cloud. So it doesn't really allow you to start off at the 100 level or the entry level and kind of build your way in. That has since changed over the past year, and we have done a lot of work in our public documentation space, especially to help people come and adopt the cloud. Because the reality is, cloud is a buzzword, right? You hear everybody saying, "Oh, I want to go to the cloud and I want to use AI and ML and I want to develop this mobile app." But the reality is, you don't know how to start. You don't know, there's so much information out there that you end up in a state of analysis paralysis where you don't know where to begin and you don't know how to begin. So a lot of the focus that we've been doing this past year is really just helping people come into switch mindsets into like, I am new to the cloud. How do I get started? How do I spin up my first VM? How do I build my first Kubernetes cluster? How do I deploy my web app? How do I build a web app? Like just walking through those basic fundamentals and helping enable everybody to use to consume cloud services as much as we can. And that's really the big drive that we have been doing this year to really just help enable everybody to use the platform more efficiently.
Okay, yes, it's good. It's interesting that you mentioned this word, this buzzword. Another thing, me as a developer, right? So I develop small apps, consumer-facing apps. Another buzzword I always hear is enterprise.
Mhm.
And then when you have to build an enterprise app, there's certain things you can't use. Can you shed some light on what's the difference between an enterprise and like a consumer app?
Yeah. So an enterprise is, if you think in a traditional sense, right? Enterprise companies are these big beasts of a company. So back home, you think of a small mom and pop shop, or you think of like a small computer parts store that sells a very specific product set, and they do a little bit of computer repair and a little bit of virus cleaning and so forth. They are your traditional small to medium sized business. But then you have the larger companies that have business processes, that have traditional workflows, that have some type of change control built in, some type of formal structure within their business process. And that's where you have companies like the telecom companies, the utility companies, like all of these big, massive companies. And when you think of an enterprise app, you have to think of the workflow associated with it. So something that might fly for a consumer app is, let's say you want to just send a text message, right? I want to let's say I'm building a text message app to communicate, like I'm building the next version of WhatsApp. If I build an app for consumer or a smaller business size or like a general consumer population, I might just say, okay, all my app needs to do is be able to send a message from one person to the next person, end the story. But now when you start introducing the enterprise piece of it, you have to start thinking, okay, well, how does that message go from one person to the other person? Is my message secure? Is my message can somebody fake my profile to send a message on my behalf? What is the accountability? What's the auditing? All those different types of components that you traditionally wouldn't have. And that's the methodology that you sort of inject into your application framework, and building those things, and then building that functionality into the app itself. And also now being able to, when you start having to introduce that type of functionality, you also have to start now leveraging concepts like CI/CD and unit testing, those kinds of things. So that's how it branches out into a normal small little project to do a simple app into a more full-scale application that has multiple facets and multiple technologies to support it.
Yeah, as an example of that, some of my team members worked on some of the apps that some of the government organizations were using around the US for like on tracking unemployment. And so, from a technical perspective, the apps weren't very complicated at all. They were just really, they were forms basically. But you had to have things like how does the government agency authenticate? That was a big deal for us. So it was like they wasn't signing in with Google or signing in with Facebook or something like that. Like they had their own type of credential management that had to follow certain rules and regulations, and then we had to be able to interact with them. So I think some of that is where when you're dealing with that on that enterprise level, you just have a lot more boxes to check other than just does it work.
Yeah, exactly.
So
It goes from a Hello World app to like an actual production level app.
So it seems to me one of the big words, one of the key concepts is scale. So it's so many customers or so many users, or maybe your user has users. So maybe a simple VM doesn't cut it anymore. So I think that's why you need this additional infrastructure, which I guess you would rely on the cloud for. And speaking about VMs, I know that's just one way. There's one kind of compute resource. So I know that cloud has many different kinds of resources. And as a developer, I know what a VM is. I could go on, these other small providers, get a small virtual machine. I could put a little website, and that works fine. When you're scaling out and when you're using like Google Cloud, for example, I see in the compute section, there are other options. So maybe you could spend some time talking about that. I see that you showed me this, gave me this handy diagram. Let's see if I could put this on screen. You could just spend some time talking about this a bit. Okay.
Yeah, sure. So I'll be looking on my monitor because I can't see too well on this one here. So
Okay.
I'm just going to talk through, go left to right on this one, right? So on the left hand, so before I start, this is what we call a GCP sketch node, and this is a new concept that we have. One of our developer advocates, Priyanka Vergadia, she's one of our developer advocates, and you can see some of her videos on YouTube and stuff covering different topics, especially in the developer space. So she put together this sketch note kind of covering all of the different compute options for code, or specifically for developers, and kind of helping you identify where what compute best addresses your need and what you're trying to do, right? So on the left-hand side, you have Compute Engine, which is your traditional VM. This is the simplest, the most common type of deployment that you would have. This is what everybody's accustomed to. You spin up a server, you run your binaries, you put your particular compilers and so forth, and you build your app, you run your app, you host it, you do all your dev work there, and good to go. The problem with that is, on top of you being a developer, now if we're approaching this from the developer context, you as a developer, you now have to worry about, is my server secure? Is my server patched? What's going to happen if my server go down, to the point of scaling? Oh shucks, I just realized my 10 people who was using this app, they posted on Facebook, they posted on our WhatsApp group, and now 100 people using it now. And this one server can no longer take that weight. So now I have to go and quickly try to spin up a next VM, rebuild everything, and try to put this together, put load balancer in front to make sure it's working. So like this now becomes additional overhead. And as a developer, I may or may not have that skill set to say, I can do this readily. So while it is a great option and an easy press button go, it's not exactly the best fit for everyone. Kubernetes, on the other hand, and actually Kubernetes and Cloud Run. The concept of containers. What I like about containers is it allows you to be completely portable. And when I say portable, I mean that in every sense of the word. So you can, on your own personal machine, at home, use like Minikube or some version of Kubernetes, or I'm sorry, not even Kubernetes, some version of Docker, build a container. You have that container built and you have that stored in a registry. You could literally just go to any other provider. You could go to Google, to Amazon, to Azure, to anybody that runs Kubernetes, and you could run that same app on your Kubernetes cluster, and it is going to work the same way as it would on your laptop or wherever you develop it on. And that's the beauty of containerization, right? It packs all of the dependencies to run that application into one very nice, small, lightweight box that can run anywhere. And the major benefit of containerization is, as a developer, I don't have to worry now about what the underlying infrastructure is. If I'm using something like Docker Swarm or I'm using something like Kubernetes, which we would obviously prefer Kubernetes because it's much more mature and much more widely adopted. Kubernetes would take care, once you configure your settings of how you want that app to run, Kubernetes could take care of everything for you. So what that means is, let's say in your application configuration file or in your Kubernetes deployment file, you say, I want this app to have at least one container running, meaning I want one instance of that app to always be available regardless of who uses it. Regardless if it's one user or 100 users, I want a minimum of one user. And then within that, you set thresholds. And you say, let's say, if I notice a spike of CPU or I notice a resource contention or whatever the case is, I want to now be able to, I want the system to automatically add resources to compensate for that additional load. That's where the scaling part comes in. And not to switch gears, but you can also do scaling in Compute Engine as well, but that is also a very heavy process, and I'll kind of circle back to that if we have some time. But within the containerized platform, when you say you want that to scale, the system will automatically, without you having to wake up 2 o'clock in the morning, realize that, okay, I'm seeing a lot more increased load coming into this container. Let me add 2 or 3 more containers based on the configuration of your application deployment to absorb that load. And the great thing about scaling is, when that load spike has gone, those containers will be discarded, so that you back with your original one. So not only does it help you absorb that load coming in, it also scales back down to save you cost, because as you increase resources, you pay for that, but then as you scale back down, you don't.
So just if I can talk about containerization, because maybe not all viewers will be to not know much about this topic, but so I know VMs is a virtual machine, is a way of creating like an isolation on a server, so many users can have a VM. I think, can you say like a container is like one step further of virtualization, such that you can run many containers in a VM?
Yeah. So I'm sorry, I should have started off with this. So your VM, whether it's a physical server or a VM, you have a few layers, right? You have the kernel, then you have the operating system itself, then you have your application. Even before the application, you have your dependencies that you need, your different libraries and so forth, and then your application on top of that. So you have 4 layers for all intents and purposes. If you were to scale that, and going back to the compute engine, if you were to set up that as a scaling, every time you scale and you build a replica on top of the application, you're also going to have those additional 3 or 4 layers below that will be coming. So every replica you have will have a kernel, an operating system, the dependencies, and then the application. So that quickly becomes very heavy and very bloated. A container basically does virtualization at a different level. What it does is, you have a shared kernel, a shared operating system, and then the dependency and the application sit within its own isolation box. So what that means is that once you have a system that meets the minimum requirements for containerization, you can move that application to any other system that has a kernel and an operating system that can support that, of course. And your application will run because you have the dependencies there and you have the application there already. and there's no additional work needed to build it.
Yes, I just did a quick Google search, and I think just to add some visualization to what you're saying.
Yeah, exactly. So on the right hand side, those binaries and the libraries is the dependencies I was talking about, and then the application that sits on top. So what a container would do is a container would take the application. So like looking at the green box on the right side, a container would encompass application one and the binaries and libraries associated for application one. So then you could take that app one now and that container that consists of app one and binary library app one and move that to any other host that supports containerization, and that application would run just as if it was on the original machine.
Right.
And that's the beauty of containerization.
Right. So, but with the Kubernetes, I would guess all of these containers would have the same app.
Not necessarily.
Okay.
So containers is a in the context of Kubernetes specifically, you have this concept called a pod. A pod is the smallest identifiable unit within Kubernetes. The pod has the container within it, but a pod can contain multiple containers. So you can have let's kind of make this a little bit more simple, right? Let's say this application here is a website, right? So you have a website. Let's call it gdg.tt. So the gdg.tt is this website that you build here, and you have your associated binaries, and you have that packaged together nicely in a container. In Kubernetes, you could have a GDG pod, but it consists of the gdg.tt website container, which will be that there, but it can also consist of having a SQL server, for example, a SQL server container. So that pod now becomes an entire, it contains multiple containers, but they all serve the same,
that's kind of logical purpose.
Exactly.
Yeah, okay, interesting. But when you're speaking about the auto scaling, right? I would imagine it would create containers with the same, basically with the same multiple instances of the same app, and then it would look like it's one actual application to the clients who connect.
Yeah. Yep. And so the way that happens is what it does is Kubernetes creates, and this is all transparent to the end user, right? Like they wouldn't know the difference. But what Kubernetes does at the minimum is you could do, and I don't want to go too deep into the weeds with this, but you have a load balancer at the front that automatically gets created. And it's either going to be something called a service load balancer or an ingress load balancer. And that is kind of out of the scope for this one, but essentially what that would do is that gives you a single front end IP address to reference that application. So on the back end, you could scale you could have 100 copies of that same application, or you could have one single copy of that application. But from the front end perspective, it's still referenceable by only one IP address. And when your users connect it, they connecting to that one IP and not to the individual IPs of the applications. So that's where the scale allows you to grow and shrink without any kind of impact to the users.
It's kind of like an invisible scaling.
Exactly.
And I think, correct me if I'm wrong, Akish, but Kubernetes will also do things like allow you to have a single data source, and it will handle like concurrent requests to the same data source, and do that like be the traffic police in that case of not having somebody be able to like spend the same money
exactly
twice.
So that's where we start getting into things like namespaces and network policies and so forth. That's really like the communication between the different services. But yeah, that there's functionality like that built into Kubernetes.
Okay, so maybe we can move on to Cloud Run.
Yeah. So Cloud Run is the easiest way to think of Cloud Run is all of the great things that you get with Kubernetes, but without having to manage Kubernetes. So what this really is intended for is for developers who just wanted to, like you have Actually, before we go to Cloud Run, let me kind of talk a little bit about the App Engine and Cloud
Functions.
Functions, and then I'll jump
Yeah,
back to Cloud Run.
sure.
So now that we have a basic idea of containerization, even though there's that advanced level of virtualization and it makes things super easy to run, there's still a little bit of overhead again, from the developer perspective, you now have to you now have this block of having to learn Kubernetes and learn the basics of it and how to build these deployments and all of those different things, right? So sometimes that could just be overwhelming, and again, it's another barrier to entry coming into the cloud. So platform, if you look on the right hand side here, you see there's a your code um, banner, and then it points to Cloud
Mhm.
Functions and App Engine. And what this means is these two offerings that we have are really designed for the developer in mind. You as a developer don't want to worry about anything, any infrastructure below. You don't want to have to worry about scaling and setting those things up and setting up thresholds. Like all of that is still a lot, kind of still falls into the operational realm versus the developer realm. The products like App Engine and Cloud Functions serve very specific purposes because they abstract all of that infrastructure away and just give you a platform to run your code. So you as a developer can say, you want to build a Node.js app, for example, and you want to do some React in front or whatever the case is. So you spend your time, you build your React front end, you have your Node.js backend, you set everything up, you have your, everything running exactly the way you want it to. It looks exactly the way you want it to. You just want to deploy that and see it run. Like that's all you want to put that in cloud and not worry about anything else. That's where App Engine will come in. App Engine is that a platform designed exactly for that, and that's where Google started. Like I said in the beginning, that's the first product that Google released in their cloud.
Oh,
So all you do is you use the Google SDK that you would install on your machine. You would make sure you have your account and everything set up. You have your authentication and everything set up in your SDK. You take your code and you just say gcloud app deploy, point it to your folder, and then that will literally just take the existing code you have, copy it up into the cloud, set up everything for you, and then give your endpoint and say, boom, here's your endpoint. Click on this, and then you can access your app. And it is as simple as that. And then when you do that, now depending on which version of App Engine you go with, you can, if you go with the App Engine standard, it will automatically just, it takes care of everything for you. It takes care of scaling. It takes care of making sure you have replicas and everything. Like it just really takes all of the weight off of you. And then you get a URL that you could click on. And then if you have a public DNS domain that you need to set up your records and so forth with, you do all of that in the backend, and then all of a sudden you now have a publicly available website that has everything. And App Engine itself is an ecosystem that contains everything you would need to run your app. So it has access to Redis or to memory store, what we call it. So if you need to have like in-memory databases and so forth, it has access to data store, which is a database specific to App Engine. It has storage built in. So it is a complete ecosystem for an application that you could literally just deploy your app there and not have to touch anything else in GCP if you didn't want to.
that's interesting. So I'm seeing the different, these arrows, and it's interesting because it's saying it's letting you know of the trade-offs. One gives you more control, but if it's more control, it's more overhead.
Yeah.
When less control, less things you gotta think about. So I guess it's pick the option that you're the most comfortable with.
Exactly. And just kind of piggybacking off of that, right? Like, let's say as you build your app, right? Like you develop this thing, and over time you have multiple iterations, multiple features, people starting to use it, or you just want to add more stuff, right? Well, let's say there's some code in there that does not necessarily need to run all the time. Like
Right.
So a real example is, let's say you have some type of intake, like you have a front-end website where a user could upload a file. And when that file is uploaded, you want your application to, let's say you want to do like a categorization, like your user is going to upload a file to you, and then you're going to use some type of logic to say, this file contains a picture of a cat or a picture of a dog or a picture of a flag or whatever the case is, right? But that code that is going to analyze the request coming in doesn't always need to be running, because you don't have a constant upload of users. People not every second uploading a file is whenever it happens. So that's where Cloud Functions come into play, and this is where you have functions as a service. So a function is a piece of code that runs only when there's an event or when there's a trigger. So in this case, the trigger for you or for the app will be when a user uploads a file to the application. When that happens, you have different ways of coding that trigger. It could be an HTTP event, it could be a GCS bucket upload. You have different ways of doing that.
Okay.
When that trigger occurs, it's going to execute that piece of code only, and it's going to do whatever logic you built into that code, and then it's going to stop. And then after that, it's going to return the results of whatever processing it did to your application or to wherever you tell it to go to. So the benefit of that is you only pay for that code execution when it executes. So from a cost savings, and this is where, like, as your app starts, as you start thinking and adopting cloud and leveraging cloud services, cost is one of the important things you have to pay attention to. And it's things like this, like determining your business boundaries or your application boundaries, of identifying things that can run once and then shut down, or run on demand and then shut down. Things like that help you control your costs, so that at the end of the day, you don't end up with $1,000 bill and you're like, what the hell, all I do is deploy a single app, right?
Right. So that's interesting, because even thinking about your example, maybe it's running some ML model in the background to do object detection, and maybe you need a lot of memory for that. So it doesn't make sense to have all of those resources available 24/7 that you're paying for if you just need it for every once in a while a user is doing an upload. So it really gets you to segment the functionality and provide and distribute availability and save costs.
Yeah, exactly. And so, the reason I wanted to talk about Cloud Run last, and I want to say one more thing on these two before we jump to Cloud Run. The downside of working with a platform as a service offering means that the supported languages that we have are limited to what the product supports. So, like, for example, and I forgot the versions of Node, but let's say, I think, I don't want to misquote the numbers, but there may not be the latest version of Node.js support available in like Cloud Functions or App Engine.
Right.
And you may, as a developer, say, I want the bleeding edge technology. I want to use like Python 3, for example. And that platform as a service offering may not offer support for Python 3, just as an example. So that's one of the downsides of using a platform as a service. You are bound to whatever languages they support on that. But the good thing is, because languages are being updated so frequently, all the cloud companies are being forced to make sure that they release support for those versions of the app or of the language very rapidly. So if it's not supported today, within a month, 2 months, 3 months of general release of that language, it should be supported in the platform. But you could run into a scenario where there is, even if the platform as a service supports the language that you want, there may be a library specific that has some type of callback to the kernel, or some type of specific callback that the platform will not do. Because as you rightfully said a few minutes ago, as you have more access to the operating system, there's more overhead. But as you have less access to your operating system and you have more of a platform, means you have less access to the underlying components. So you are, because of it's a secure boundary, you can't really necessarily access every single thing you could traditionally do on a compute engine where you have full access to the kernel and everything like that, right? So, and this comes into play, like the only example I can think about is in like MySQL, right? There's a specific issue where you're trying to run some queries and there's a hard limit within, or soft limit, I should say, within the application, within MySQL itself, that prevents a certain amount of queries from being run. There's a flag you could enable that it makes a kernel call back to the operating system to make that adjustment and allow you to do it. But you could only do that on a compute engine instance where you have full control of the kernel. You can't do that on a managed platform. So that's an example of like something that your application may need to do that it might not be able to do on a platform as a service offering. So Cloud Run is kind of that hybrid in between. Cloud Run allows you to do the same thing of it, and it's properly positioned in the middle. It gives you access to a lot more components in a language or in a server or in a operating system than you would traditionally get in a platform as a service offering. You still don't have full kernel access because there's a security boundary there, but you have a lot more flexibility where if there's a particular library or there's a particular dependency or there's a particular function or some type of code that is not suitable for App Engine or Cloud Functions, and you don't want to go and have to learn Kubernetes, Cloud Run gives you a container as a service essentially. So you can go ahead on Docker, you could build, you follow the same methodology, you build your application, you make sure you have all your dependencies and everything set, and then you just run that in Cloud Run. Now, Cloud Run runs on something called Knative. Knative is an open source project that Red Hat and Google and IBM and Pivotal and a few other companies, I forgot the others, they contributed to. And what it does is it introduces something called a primitive. And a primitive is a building block in Kubernetes. And the easiest way to think about it, or to think of a primitive is, like let's say you're building a house. Your foundation that you put down is going to be Kubernetes, right? Mm-hmm. Or your infrastructure, let's say. And the framing of the house, when you pop your bricks and you do the wood framing and all of that, that is Kubernetes. That's going to keep everything nice and safe and secure. Your car that after you build your house now, you want to take your car and you want to drive and put it in your garage, right? So your car in this example is your container. So you go, you put all you get the car you want, you customize it how you want, you add your little rims and so forth and whatnot, and you drive that into your garage and you use that as your application. But nothing's stopping you from taking your car and carrying it by your partner house to go online, or nothing preventing you from taking that car and going to watch a movie, or, well, I mean, now with COVID, you have a little bit of restrictions, but I mean, conceptually, nothing preventing you from driving your car to go somewhere else. And that's where Knative comes in. Knative is that library that runs on Kubernetes, and it allows you to take those applications that you will be running in Cloud Run and move that Cloud Run container into Amazon or into Azure or to on-prem or anywhere that you run Kubernetes that has the Knative primitives. So it's just an interface that allows the application to interface with Kubernetes and really embrace that serverless type of methodology. So it's, I guess let me kind of pause there because I kind of cover a lot of information. So let me save a little bit of space for some questions.
Okay, so the way I've seen some getting it is Cloud Run is another way to go about with VMs, containerized applications, but you don't have to think about Kubernetes as much
at all.
Okay.
So there's this concept called serverless, right? Serverless serverless is a misnomer because ultimately the code or whatever you're doing, it still runs on a server in the backend. But the term serverless basically tries to abstract everything below the application level down. So as a developer, serverless is one of the great attractions to cloud, because you as a developer just want to place your code somewhere and you don't want to worry about nothing else.
Yeah. Cloud
Run, and that's exactly what App Engine is. App Engine is just a place to go deploy your code, and then you don't worry about nothing. You don't worry about any of the underlying infrastructure. You don't have to worry about having multiple copies for redundancy and backups, and all of that is taken care of for you.
But you have to worry about but you have to only use the dependencies that are available in App Engine and Cloud Functions.
Yeah, exactly. And Cloud Run just basically extend that so you have more flexibility with your language, but it also gives you the benefits of serverless, where you don't have to worry about setting up Kubernetes or anything like that, but you have the flexibility of what Kubernetes brings to you.
So So does that mean you will need to install and or at least set up your container to know what dependencies your app will need?
Yeah. So when you build
Okay.
your Docker container on your laptop or wherever you build it, when you do the Docker file, you would have to set up all of that or
Right.
declare whatever your dependencies are going to be, and then your application code will then sit inside of that.
So question, I am a little familiar with Docker, and you could create a Docker file. So say I create a Docker image, what will be the difference in using that Docker image with the Kubernetes engine versus with Cloud Run?
So the only difference is with Kubernetes, you will have to, in addition to deploying that container, you would have to do something called a deployment file or an application deployment file. And that's where it's a YAML-based file where you have to declare like the pod names, and you have to declare how much replicas and any security context. So like that's where the operations piece of it still comes in. So there is some overhead and a learning curve to having to understand Kubernetes. Even if you go with like a managed Kubernetes offering, like for example, if you go with Google Kubernetes Engine, which we manage the infrastructure for you, you still, when you're deploying your app, have to configure that deployment file to run your container. So there is still a learning curve there. With Cloud Run, you literally just run your container. That's all you have to do, and we take care of everything else for you.
What is the trade-off between, because I know all of these have trade-offs. What's the trade-off? What do I lose by using Cloud Run over using Kubernetes? If I'm a Kubernetes expert, what am I giving up if I use Cloud Run?
So it depends on the use case, right? There is the easiest one that comes to mind is well, there are a few. The customizability of the interactions, the namespaces. So a namespace in Kubernetes is a logical grouping of resources that serve a particular purpose. So if we go back to the original example, we were talking about the front end for gdg.tt. A namespace in this process might consist of your web front ends. It may consist of your applications and your SQL servers. Let's just say, right? So that namespace within Kubernetes will be will basically be your for the gdg.tt app. In Cloud Run, because you're just deploying the container, you don't have as much. You still have flexibility to configure like what access it has. It's just you don't have the level of control that you would typically have with like your network policies and with like your more advanced configurations in Kubernetes to basically say, I want this app to run in this particular way as if I was running in Kubernetes. You do lose advanced capabilities by moving to a managed service like Cloud Run, but you gain the ease of use because you don't have to worry about managing that underlying infrastructure and managing those different policies and so forth to get thing up and running.
Right. So it seems that some decisions you may have in running it is made for you in Cloud Run, and then Kubernetes would still give you the flexibility to decide on your own.
Yeah, exactly. It's an opinionated way of us helping. We just want to make it easy for you. So when providers make things easy for you, there are some certain assumptions that are made, and those assumptions may not necessarily align with how you want things to run. But as a starting point, it's a great resource to get into cloud and to get to run and to play around with the technology. And more often than not, 80 to 90% of developers will find that platform as a service offerings provide the level of functionality they need for their application. There are those certain use cases where you have to you really need to have some type of control, or there's some like a very real scenario where you would pick Kubernetes over Cloud Run is, let's say, as an enterprise company, your security team says that I need to have certain security policies in place to ensure that traffic can only communicate from one spot to the other spot and nowhere else. While you can accomplish that to some extent in Cloud Run, you cannot you can't get the same level of flexibility as you would in a traditional Kubernetes cluster, where you can go in and declaratively say, this machine or this pod or this namespace could communicate with this namespace, and I could control that on my own. So there's some trade-offs, and it depends on the business requirements. But from a developer's perspective coming into the cloud, you would always want to target the platform as a service, because that's going to be your easiest way to get into the cloud and to get an understanding of how cloud technology works. And then from there, if your requirements, if the requirements of your application grows beyond the scope and the capability of the platform as a service offerings, that's where you would
Hey, I
start.
think the audio dipped on my end.
Oh, you can hear me now?
Hello?
Yep. Can you hear me?
Can you all hear me?
Yeah. Can you hear me?
Yeah, we can hear you.
Strange. Arthur, can you hear Akash?
Yes.
Okay. Akash, can you say something?
Yeah. What about now?
Well, I would assume that it would still be on the air. So
Should
my
be.
next question would be, well, actually, I think, okay, so that's a really good overview of compute. You want to talk about any other products in GCP that will be, developers may be interested in?
Yeah, so AppSheet is, I know we talked about that at the beginning as a potential product to talk about. It's a pretty new product to GCP, so I don't have too much context about it, but my understanding of what it does is it gives you a low code interface to basically build workflows between your products. So it's a GUI based tool that you can build your different integrations and your customizations to build some type of workflow or application front end without having to go in the back end and type up code and build specific APIs and that kind of thing. Like that, the point of it is it's already pre-compiled code that you just drag and drop to accomplish a specific task.
Okay. One thing I came across is Anthos.
Mm-hmm.
Can you talk a bit about that?
Yeah. So Anthos itself is a fairly complex topic, but the real value of Anthos comes in for enterprises and for people who run Kubernetes in multiple locations. So the easiest way to think about this, let's say you are a developer, or your company comes to Google and says, I want to use Google Kubernetes Engine, which is the managed version of Kubernetes. And I want to deploy my code here, and I want to deploy my containers, and I set everything up, and I love the way it's working, and happy with the experience. But then for another reason, the business may say, hey, you know what, we need to deploy another Kubernetes cluster on-prem in our data center or in our office. But I want to be able to have that centralized visibility. That's where something like Anthos will come into play. So if we focus back on Kubernetes Engine, Google Kubernetes Engine, and we go back to that scenario where we have one namespace could only talk to the other namespace, but it can't talk to the other namespace, or you have like certain restrictions in place. Or another real one is, let's say you have your development team and your production team. You wouldn't necessarily want to have your development team who will be doing disruptive changes to the application to test different things to also have access to the production team, because sometimes mistakes happen, human error, and this a developer team might release some new function that just completely breaks the application, and they may inadvertently select the production application. And when you do that, you just take down your whole business, right? So there's some boundaries that you set up. And let's say for the security team, or even your local operations team says that we want to build certain restrictions in how different applications can communicate to each other. And we also want to build restrictions into who in my business or who in my team can access which resources. So that template now can be very complex very quickly as you start adding different variables and different environment changes and different restrictions. It can get very, very messy very quickly. When you say, well, and then the business says, hey, you know what, we actually need to build this on-prem in our data center or in the office as well, and we need to replicate this one for one. You know, as an operations man has to, or woman has to go in now and make sure you copy that configuration from Google Kubernetes Engine and replicate that one for one on the open source version of Kubernetes. Because keep in mind, Google has it when you run a managed version of Kubernetes anyway, it's that particular provider's opinionated version of Kubernetes. Like they make their own customizations and their APIs and so forth. For the most part, it follows the same structure as open source Kubernetes, but there are some minor modifications that can be made. So now your business is telling you in your data center or in your office, you have to run this open source version of Kubernetes, which is a pure version of Kubernetes that may or may not have the same functionality as your managed offering in Google Cloud. You as an ops person have to now translate those restrictions and policies and so forth onto that on-prem cluster and make sure that everything is working the way it should. And guess what? As soon as you do that, the business comes and says, hey, actually, we have this customer who says we have to use Azure. They don't want to use Google Cloud. We have to deploy this thing in Azure, but we need the same setup in Azure. Guess what? Azure has a managed version of Kubernetes as well, and they have their own customizations. So now you as an ops person have to maintain Google Kubernetes Engine, you have to maintain open source Kubernetes, and now you have to maintain Azure Kubernetes. And that now becomes, it's a nightmare, right? Because all it takes is one mistake and you could just blow away the entire configuration. And this is where the beauty of Anthos comes into play. Anthos is a single management interface. So you would still manage it from the Google Kubernetes Engine webpage or the console, but it ties into the on-prem database, on-prem Kubernetes cluster, the open source cluster, and it also ties into the Azure version of Kubernetes, or where we would deploy our specific version of Kubernetes in Azure, in the Azure data center. And you manage all of that from Google Kubernetes Engine front end. So when you deploy a policy, a security policy, or a restriction on who can use what access and whatnot, that access is transient across all of the clusters. So from a management perspective, it solves so many problems because you now have one source of control and one source of authorization and access management that you could control across everywhere you run Kubernetes. And then from a developer's perspective, especially, the reason I call out having different APIs when I was talking before is when you deploy your app, if you are, depending on how advanced you get into Kubernetes, you may want to leverage certain types of features and functionalities within a managed version of Kubernetes, or even the open source version of Kubernetes, but the APIs might be different. So in your code, you may have written your application to reference the Google Kubernetes API, but those Kubernetes APIs may not work in the Google Kubernetes API calls may not work in the Azure Kubernetes calls. And that obviously is going to cause a problem because now you have to maintain multiple versions of the APIs, you have to do environment checks, and it just becomes overwhelming for the developer again, because now you have to worry about infrastructure and not just build your code.
You could give an example to one of those API calls that might be different from Azure to manage to open source Kubernetes?
Nope, I have no idea. Well, I mean, there are some, but I don't, like, I'm not that deep in the developer space to know, like, to give you like an actual material example. But it is a real type of issue, right?
Yeah.
But the benefit of it is with Anthos, when you deploy that Anthos setup, you have one set of APIs. So when you build your application, you are referencing that one set of APIs, and it doesn't matter if you run that container in Azure, doesn't matter if you run that container in AWS, doesn't matter if you run it on-prem or in Google Kubernetes Engine or somewhere halfway across the world in somebody's data center. It doesn't matter where you run it. Once it is managed by Anthos, it adheres to a single set of APIs, which is where the tagline of Anthos comes in: build once, run anywhere. So it really, from a developer perspective, makes it super simple because you get to focus back on your job as a developer, your passion as a developer of building an application, and letting it run wherever it runs, and let the operations folks deal with managing everything else.
Okay, that is great. I think we had a really great session. Covered a lot of stuff in compute and other products that's available in Google Cloud. I would say thank you again, Akash and Arthur, for enlightening us here at GDC POS. It's always nice to talk to Trini Googlers and connect, and so we can learn more about the technologies and the platforms that are there. Any last words from either of y'all if you want to say before we wrap up?
Yeah, I mean, feel free to look me up on LinkedIn if you have any questions. Nicholas, you have my email. Please share it with everybody. But yeah, I mean, any questions, any concerns, you want to learn more about GCP, you want to have a more specific conversation about a particular technology, you want to get some training, whatever, please feel free to reach out to me, and I will try to do my best to help you.
Yeah, I think it was useful. Thanks for all that context, Akash. I learned a lot as well. I want to point out, like, Firebase is also connected to GCP as well, in the sense that if you use Firebase, the functions that we use in Firebase are actually the cloud functions that Akash was referring to. So a lot of the same ideas come about because Firebase is so tied to GCP. But another thing I wanted to point out about containers before we go was just the idea that in deploying to production is one way in which containers can be useful in terms of using it with Kubernetes and things like that. But also the development process could also be used with containers. So if you and your team working remotely, as a lot of us doing now, like having that consistent environment in which everybody developing in is also an option for using containers.
For sure. So thanks again, guys, and that brings us to an end towards this session. So, oh, that ended abruptly. Okay, so I hope you all found that presentation to be useful. I certainly learned a lot. And of course, they've only been talking about the compute options. So GCP has other product categories. But I think when it comes to, just developers building mostly consumer apps, the compute ones are the ones that are most relevant to us. So in wrapping up, I just want to show you all to direct you to some resources. QuickLab is a really nice site because it's Google Cloud training, right? So it gives you tutorials, gives you quests where you could earn badges. And if you're even interested in pursuing certification, Google Cloud certification, this is a really good place to start. Of course, we will give you access to all of these things, all of these resources in our post-event blog. Just keep following us on social media, Facebook and Twitter, and you'll get these things, as well as how you can contact our various speakers like Akash and Arthur and whoever else appears in these events. So that more or less brings us to the end of today's event. I hope it was useful and educational. Next up, coming up really soon, is our yearly annual Dev Fest, and it's just basically a show and tell for developers. Right? Anything you're passionate about to give a technical presentation on, we give an international platform for developers who have something they want to show. Right? This year, DevFest is going to be, of course, totally virtual. That only means that the audience is going to be even larger. So we're teaming up with the Latin American region, and we're having an English track. So because the English speaking countries of Latin America is the Caribbean. So you can look out for details on GDG Caribbean and our call for speakers if you're interested in becoming a speaker for this DevFest event. So that more or less brings us to the end of the event today. I hope you all enjoyed it. I'll see you in the next one. Bye.